CcpN encourages its users to use atom names which follow the NMR Exchange Format or NEF convention. This will ensure compatibility with other NMR programs and the BMRB database. The atom names used by the NMR Exchange Format are based on the IUPAC atom names. So for alanine, for instance, you can see them all here. Note that for the amide group, the atom names are simply H and N, not HN or NH. And similarly for the carbonyl-carbon, the name is simply C, not CO or C'. The reason we can't just use IUPAC names when doing NMR studies is that NMR has a number of specific additional requirements. While IUPAC has individual names for each hydrogen in a methyl group, for example, NMR can almost never distinguish between these atoms. You will generally only see a single peak for a methyl group due to the fast rotation around the C-alpha, C-beta bond, which interconverts all three hydrogen atoms. NEF therefore uses a single name for all three methyl hydrogens. This is HB%. What this means is that this is HB1 and HB2 and HB3. Now let's have a look at what can happen in the case of a serine, for example. Here we have a CH2 group. Note that this is a prochiral group. Although the C-beta is not a chiral centre, the two hydrogens are stereochemically distinct. If these two bonds were in the plane, then one of these would go back and the other forward, so they are distinct. Now, what kind of peaks might we see for such a CH2 group in our NMR spectra? Very often you will see two peaks, one for each hydrogen. But on the whole, we do not know which peak belongs to which atom. We don't have a stereochemical assignment. NEF terminology therefore names these two atoms HBX and HBY. Note that which peak or atom is given the X and which the Y name is entirely arbitrary. What this XY terminology essentially means is that HBX or HBY is HB2 or HB3. So we had the percent nomenclature as an AND operator, and now we have XY essentially as an OR operator. Now, the other situation we may have in our NMR spectra is that we have a single peak for both of these hydrogen atoms. In this case, either there is dynamics or perhaps these two hydrogens simply have a very similar chemical shift. This time we can't distinguish between the X and the Y, the 2 and the 3 hydrogen. So instead we go back to the percentage nomenclature. Essentially what we're saying is that this peak or this atom refers to HB2 and HB3. What about aromatic residues such as phenylalanine and tyrosine? IUPAC again has fixed definitions for the name of each atom. This is based on the dihedral angle around the C-beta C-gamma bond, i.e. the angle which the aromatic ring makes with the rest of the amino acid. So as the structure changes, the atom names may change. Now typically we don't know what that angle is, so HD1 and HD2 are indistinguishable to us as NMR spectroscopists, and the same for HE1 and HE2. We therefore use the XY nomenclature. HD2 and HD1 become HDX and HDY, or the other way round. And the same here for the eta group. But of course, in most situations, the aromatic ring flips sufficiently fast that you only see a single peak for the HD1 and HD2 in your NMR spectrum. So what we then use is the HD% nomenclature. And the same for the etas, we use HE% when there is ring flipping. Finally, we need to note that the carbon atoms, which these hydrogens are attached to are given equivalent names that match the hydrogens. So if this were HDY, then this would have to be CDY. If this were HDX, this would have to be CDX. If these two atoms are both HE%, then these two atoms here both need to be CE%. Finally, let's look at a valine residue, which has two methyl groups attached to the same carbon atom. And the same issues apply to leucine. This is again a prochiral situation, where the two methyl groups are stereochemically distinct. So IUPAC has individual atom names for all 6 methyl hydrogen atoms. But of course we know that for each methyl group the hydrogens are indistinguishable by NMR. So we use the percentage nomenclature, and Hg1, 2 and 3 simply become Hg%, and Hg21, 22, 23 become Hg2%. Let's have a look at what we might expect to see in an NMR spectrum. Often we will see 2 peaks, one for each methyl group. Usually we don't know which peak belongs to which methyl group. There are ways in which you can get this stereochemical assignment, but for standard experiments on fully carbon-13 labelled proteins, we don't normally know which peak arises from which methyl group. So we use the XY nomenclature. This turns the hydrogens in our methyl groups into HgX% and HgY%. And once again, it's entirely arbitrary which is which. On some occasions, of course, you will only get a single peak for both methyl groups. For example, if the residue is highly dynamic or the chemical shifts are just very similar. In this case, we again use the percentage nomenclature, and all hydrogens are labelled the same as Hg%. Note that as with the aromatic residues, the carbon atom names have to match the hydrogen ones. HgX% is bonded to CgX. HgY% is bonded to CgY. And if we're using the Hg% nomenclature for all of our hydrogens, both of our carbons become Cg%. Note that you will need particular types of experiments, such as a proton-carbon HSQC or as HCCH toxy, to link the carbon and hydrogen atoms that are bonded to one another. So remember, HgX% or HgY% means Hg11 and Hg12 and Hg13, or Hg21 and Hg22 and Hg23. Similarly, Hg% in fact means here we have Hg11 and Hg12 and Hg13 and Hg21 and Hg22 and Hg23. You can find information on all the NEF atom names both on our website and within the CcpNmr analysis program. On our website, simply go to Support and then Manual and Video Tutorials. Here you will find a section named NMR Exchange Format. And here there is an item on NEF atom names. Here I will place this video and you can see lots of written information about the naming, followed by a full list showing all the atom names for all the standard 20 amino acids. Within the CcpNmr analysis program, you will find that if you've added a chain to your project, you can go to Molecules and then Residue Information. This will show your chain at the bottom, your sequence, and at the top, if you select that chain, it will give you information about all the occurrences of that particular amino acid within your sequence. And then on the right hand side, you get again this image showing the NEF atom names. You will also find that as you do your assignment, if we open the peak assigner and you wish to add a new NMR atom, in the NMR atom name drop-down, you will get all the NEF atom names, and if you select an amino acid type, it will specifically filter the atom names by those which apply to that amino acid type.